Well, 24th question. Two bodies of masses 3 kg and 2 kg are connected by a long string and the string is made to pass over a smooth fixed pulley. So pulley is there and masses are there connected by a long string and the string is made to pulley. So let us plot out the picture. So here is your pulley. So two strings are there. One mass is 3 kg and the other mass is 2 kg. So clearly 3 kg is greater when compared to 2 kg. Are connected by a long string. Is made to pass over a smooth fixed pulley. That's it. Initially the bodies are held at the same level. Okay. And released from rest. Over. So no doubt when released from rest it will accelerate downwards and here it will accelerate upwards because 3 kg is greater than 2 kg. The velocity of the 3 kg body after 1 second is time is given and asked you to find out velocity. Before finding out velocity v equals to u plus at, first of all find out the value of a. So the same equation children. So two cases conditions are here. Well, if you consider the 2 kg mass, here it is your 2 kg. Okay, the tension must be acting upwards, same tension, and this is 2g and accelerating upwards. Equation for this is given as accelerating upwards because of this tension. T minus 2g is equals to 2a. And for the second case you have this is your 3 kg mass, 3g acting downwards and tension is acting upwards, accelerating downwards. So equation is written as 3g minus t is equals to 3a. Solving the two, we will be getting minus t and plus t gets cancelled. So you are left with 3g minus 2g is g is equals to 5a, or a is found to be g by 5. The value of a is found to be g by 5, but the value of g itself is given as 10. Hence a will be equals to 10 by 5, or a can be written as 2 meter per second square. But as you are asked to find out the velocity, so the value of velocity can be written by using the kinematics equation. First equation as v is equals to u plus at, because the body starts from rest. Initially it starts from rest. 0 plus acceleration is 2 and after 1 second you are asked to find out. Time is given as 1 second. So v is equals to 2 meter per second and option 1 must be true. That's it. Well, and now let us move to the next question, that is question number 25. So what is given children? A body of mass 3 kg which is on a smooth inclined plane making an angle of 30 degrees to the horizontal is connected by a cord. Cord means rope, passing over a light frictionless pulley to the second block of mass 2 kg hanging vertically. So one is kept on the inclined plane, the other is hanging vertically. You are asked to find the acceleration of each block and the tension of the cord. Okay, so as usual let us plot out the diagram for this. Something like this, inclined plane. So a block of mass 3 kg lying on a smooth inclined plane. I'll take a block. So here is your 3 kg block and this is being connected with the help of a pulley. Yes, what is given children? This is your 3 kg mass and here it is 2 kg mass, pulley and the cord, everything was being given. Angle of inclination was given as, this is given as 30 degrees. That's it. Anything else? So block of mass 3 kg which is on a smooth inclined plane making an angle of 30 degrees to the horizontal. With the horizontal inclination is making 30 degrees. Connected to the cord passing over a light frictionless pulley to the second block of mass 2 kg hanging vertically. So what is the acceleration of each block? Suppose if this block is accelerating, no, we are not aware which block is moving which side. Okay, in order to find out which mass is heavier, first of all, let us try to find out the forces acting on this. So here, no doubt, the weight acting is because of the same weight, that is 2g, that must be acting here. But here, if you observe, the total weight of the body 3g must be acting downwards, and this is resolved into its component vector. Here, if 30 degrees means here also 30 degrees. I told you in the concept, because if this is a perpendicular line to this and this is a perpendicular line to this, angle between two perpendicular lines drawn will be the same, okay, because this and this are perpendicular, this and this is perpendicular. Here 30 degrees means here also 30 degrees. So this 3g is resolved into two components. Horizontal component given by 3g cos 30 degrees and vertical component is given by 3g sin 30 degrees. So sin 30 is 1 by 2. So this will be equals to how much, children? 3g sin 30 means 1 by 2. It is nothing but 3 by 2g is nothing but 1.5g. But here 1.5g and here it is 2g. So which one is more? So clearly 2g is greater when compared to 1.5g. Hence, no doubt a further system, if you consider as 2g is greater than this 1.5g, it must be accelerating downwards and this must be accelerating upwards. So now, as usual, let us try to plot the free body diagram. So tension acting in the string is taken as T. So first of all, let us try to picturize this, children. For the 2 kg mass which is hanging vertically, 2g is acting downwards and tension T is acting upwards and acceleration downwards. Equation of motion. Equation for this is given as 2g minus t must be equals to 2a. Let us keep it as equation 1. So now the inclined condition. So for the inclined condition, if you consider this, what is this, children? This is 3 kg. Well, upward force is tension and the downward force is 3g sine 30 degrees. And it is accelerating upwards. So equation for this is written as t minus 3g sine 30. 3g sine 30 is 1 by 2. Okay, 3g sine 30. Sine 30, 1 by 2 I wrote it. Must be equals to 3a. Solving the two equations as usual, what will be getting? Minus t and plus t gets cancelled. So you are left with, so what is that left with, children? 2g minus 3g by 2 is equals to 2a plus 3a will be of 5a. That's it. Well, this is 3 by 2g means 1.5 and this is 2g. Solving the two, what will be getting, children? So 2g minus 3 by 2 is 1.5g must be equals to 5a. 2 minus 1.5 is 0.5g is equals to 5a. Let us take g as 9.8. Okay, for 0.5, let me write it as 1 by 2 and this is 9.8 must be equals to 5a, and this goes 4.9 times. Hence, the value of a is found to be 4.9 upon 5, and whose value is nothing but, what is the value, children? So a is equals to 4.9 upon 5. This is 0.95 45. 85 is 40, so 0.98 meter per second square. Is there such an option? Yes, here 0.98 meter per second square. Let us see. Let us also try to find out the tension in the cord. So in order to find the tension in the cord, let's substitute the value of a in either of the equation, first equation or second equation. So let us substitute the same in first equation. We have 2 into g value, let me take it as 9.8 minus t must be equals to 2 into the value of a is 0.98, or 2 into 9.8 is 19.6 minus t must be equals to, this is 1.96. Okay, or bringing the minus t other side, t must be equals to 19.6 minus 1.96, or the value of t can be written as, what is the value of 19.6 minus 1.96, children? It must be something like this. 0. So here we have 4 and here we have 6. Well, is it 8 minus 1 is 7. So 17.64. What is the answer? 17.64 newtons. And hence, no doubt the correct option is acceleration. We got it as 0.98 meter per second square, whereas the tension in the string we got it as 17.64 newtons. Hence, the correct option is option number 1. Okay. Well, so shall we move to the next question? Okay. So moving to the next question, that is question number 26. Well, as shown in the figure, two blocks of masses 4 kg and 6 kg are placed in contact with each other on a frictionless horizontal surface, as shown in the figure. It's very clear. If we apply a push of 5 Newton on the heavier mass, so 4 kg, 6 kg, heavier mass is 6 kg. So you have applied a 5 Newton force on the 6 kg mass. So the force on the lighter mass will be, so this was, we have already solved this type of numericals in the beginning of this concept, something like this here. If you observe, some force must be acting. So this force you are asked to find out, the force on the lighter. So because of this force, some contacting force is acting on that contacting force, we'll take it as F dash. So that contacting force you are asked to find out. Simple. First of all, before solving, let us try to find out the acceleration of the system. Acceleration of the system is nothing but the total force acting upon the total mass. That's it. Well, so acceleration, what is the total force acting, children? 5 Newton upon total mass is 10 kg. Or after solving this, what you are getting is 5 goes 2 times this equals to 1/2 meter per second square. Keep it aside. 0.5 meter per second square. In order to find out this net force, it's very clear that because of this contacting force, this 4 kg is set into acceleration, accelerating this way. Okay. And so F dash, because of the contacting force, the 4 kg mass is set into acceleration, that is 4 into A, or F dash is equals to 4 into 1/2. Simplify this, you get 2 gets 2 times, and hence the contacting force F dash is equals to 2 newtons. That's it. Well, so the contacting force is found to be 2 newtons. That's it, children. Well, now moving to the 27th question. Okay. So what is the 27th question? In the above problem, the same problem. The above problem, if a push of 5 Newton is applied on the lighter mass, something different. So here 5 Newton is applied on 6 kg mass because heavier mass. Now the same numerical, but the 5 Newton is force is applied on the 4 kg mass. Let us drop out the diagram. So what is given, children? Here one bigger mass is given, this is 6 kg, and another smaller mass is given, this is 4 kg. So this is what was given. Well, so how much is that? 6 kg, and here this is 4 kg. Everything it was kept on a horizontal smooth surface. That's it. Well, so earlier 5 Newton force is applied on 6 kg. In this case, the same 5 Newton force. So look back the question. 6, 4, 5, 6, 4, 5 this way. So in the above problem, if a push of 5 Newton is applied on the lighter mass, the force exerted by the lighter mass on the heavier mass will be. So this is the contacting force you are asked to find out in this direction. So if the force is been acting in this direction, it will be, the system must be accelerating in the towards the left side. So clearly we know that the acceleration is equals to the net force acting to the total mass. Well, hence the value of A is found to be, force is acting is 5 Newton and mass is equals to 6 plus 4, that is 10, and hence the value is 1/2 meter per second square. Common, same. Now what happens means, because of this contact force, this 6 kg mass is set into acceleration. F dash is equals to 6 into A. F dash is equals to this mass into acceleration. Mass is 6 and acceleration is A. Or F dash is found to be 6 into 1 by 2, and this value is no doubt it is equals to how much, children? It is 3 newtons. How much is that? So 3 Newton option is not there, so we can directly take the option as none of the above. Okay, so what is the answer? Answer is 3 newtons. So there is no such option in this. So take the fourth option as none of the above. Now moving to the next question, 28. In the above problem, the acceleration of the lighter mass will be, my god. Okay, so what is the lighter mass? This is a 4 kg, and what is the acceleration with which it is moving on? 1 by 2 meter per second square. Is there an option? Yes. The lighter mass, whether it is a lighter mass or the heavier mass, both are accelerating together, and that acceleration is nothing but the total force acting on the system to the total mass. And this is found to be the net force acting on the system is given as 5 Newton. Excuse, and mass is given as 6 plus 4, that is 10, and hence we solve this as 5 goes 2 times, that is 1 by 2, hence the value of acceleration is found to be 0.5 meter per second square. Hence option number A must be true. Okay, children. Well, now moving to the next question, that is 29th. It's almost similar to the previous one, but two different forces are acting in the opposite direction. So two blocks are in contact on a frictionless table. One has a mass m and the other has mass 2m as shown in figure. Force is applied, F is applied on the mass 2m, then system moves towards right. Okay. Now the same force F is applied on m. The ratio of the forces of the contact between the two blocks will be in the two cases respect. Here two different cases are given. So initial case, if you are observed, so let us not bother for this. So initially case 1, if you observe, the force is acting in this direction. So let us try to solve the case 1. In the case 1, ratio of the forces of contact, this F dash you are asked to find out. Contacting force F dash you are asked to find out. So I'll keep it as case 1 means F dash 1. So first of all, let us try to find out the acceleration of the system. The acceleration of the system is equals to the net force acting to the total mass. So this acceleration is found to be net force is F and total mass is 3m. That's it. So A, we got it. The ratio of the forces of contact between the two blocks. But you're not asked to find out the acceleration. You're asked to find out the F1. So in order to find out the value of F1, I'll take in green color. So we have the force is applied in this direction. The system is accelerating in this rightward direction. So F dash is equals to this pushes the smaller mass with some acceleration. So MA, or this can be written as MF by 3M. Keep it aside. Now let us also move to the case 2. So moving to the case 2. In case 2, what is there, ma? So force, the same force F is applied on smaller mass. So the picture changes. So in case 2, so this force is applied towards left side. So as a result, the system must be accelerating left side. Okay. So as usual, find the acceleration. Acceleration is nothing but F net upon the total mass. So acceleration is F net is nothing but F by total mass is nothing but 2m plus m is 3m. So this is your acceleration. Once you got the value of acceleration, let us try to find out the contacting force. So what is the contacting force? The contacting force between the two systems in the leftwards, let us take it as some F dash. In the second case as F2 dash. So clearly we have, because of this contact force, this 2m is set into acceleration. So then this force is equals to 2m into A, or F2 dash is equals to 2m into the value of F is nothing but the same force, that is F upon 3m. That's it. So this is your second case. In first case, the force was found to be mf by 3m, and the second case it was found as 2mf by 3m. Okay, well, now you're asked to find out the ratio of the two masses. So F1 dash is to F2 dash is nothing but m F upon 3m is to 2mf upon 3m. So let us solve the same. So here m gets cancelled, f and f gets cancelled, 3m and 3m gets cancelled. Hence clearly we have f1 dash is to f2 dash is equals to, here nothing is left over, so 1 is to 2. Is there an option? Yes, of course. So option B must be true. What is the answer, children? The correct answer is 1 is to 2, second option. Clear? So two different cases you have to consider. Well, now moving to the next question, 30th. A monkey of mass 20 kg is holding a vertical rope. The rope will not break when a mass of 25 kg is suspended from it, but will break if the mass exceeds 25 kg. What is the maximum acceleration with which the monkey can climb? So first of all, you have to take the rope. Yes. Okay, and who is there? Again, our friend has come. Who is that? Our monkey. Well, so this monkey, come on, ma. Well, so this monkey mass is given as 20 kgs. Holding a vertical rope, the rope will not break when the mass of 25 kgs is suspended from it. Clearly, children, the monkey mass is only 20 kgs. Okay, but the breaking stress, okay, the breaking stress of the rope may break at whenever we have applied a force more than 25 kgs. More than 20. What is the maximum acceleration with which the monkey can climb? Okay, as usual, so clearly we have here the tension must be acting in the string and the weight of the monkey must be acting downwards. If you picturize this, the free body diagram, so clearly 20G must be acting downwards and the tension T must be acting upwards. Okay, so based on that, if you consider the breaking stress, what is the breaking force given, children? The breaking force is given as 25 kgs. Is that clear? Well, so we have as it is moving upwards, upward motion means directly we will take the value of T as m into G plus A. This is better. So we know that in the lift cases, everything, when upward motion is taken as T equals to m into G plus A, and the downward motion it is taken as m into G minus A. So we are aware of that. So T can be written as, what is the mass of the monkey? It is 20, and gravity value they have asked us to take it as 10 plus the value of acceleration, okay, unknown. That's it. Well, T is equals to, and how much tension? The tension breaking stress, when will it break? If it exceeds of 25 kgs. So T can be substituted as T is equals to 25 Newton, 25 G. Force, breaking force is 25 into 10. So if B must be equals to 250 Newtons. That's it. So tension is equals to 250 Newton. Until then it can withstand. So 250 is equals to 20 into 10 plus A, or this 0 and 0 gets cancelled. So 12.5 must be equals to 10 plus A, or A is equals to 12.5 minus 10, that is equals to 2.5 meter per second square. So the rope will not break until it moves with an acceleration either 2.5 meter per second square or lesser than that. Either the A value lesser than or equals to 2.5 meter per second square, the rope will not break. If it exceeds this value 2.5 meter per second square, no doubt that rope will break. I hope the concept is clear, children. What is the tension it can withstand? The tension it can withstand is up to 25 kg. 25 kg mass means tension is equals to 25 G, that is 25 into 10 is nothing but 250 Newton. So T is 250 Newton. So T equals to m into G plus A, as it is an upward motion. So substituting the values, we have got the value of acceleration as 2.5 meter per second square.